cool. Well, we ordered this and we drove all the way to Kentucky to pick it up. This is going to be the new bandsaw feeder. Hey, what's up everybody? Welcome to Never Stop Building. My name is Jason, and the project we're working on today is installing this Co-Matic AF19 bandsaw feeder on my Laguna 18-inch Resaw master. We're going to walk through the whole installation process and any details that might be relevant to your application, and then I'll give you a bit of a review and we'll start making some sawdust. So let's get started. Hey, while you're watching me unwrap this, I just want to jump in and say that this is not a sponsored video and nobody asked me to make it. There wasn't a lot of information on the install of these, so I thought I'd just share it with everybody. All that I have to say about it is just my opinion. This thing is big. Oh my God, and heavy. Oh boy. Yeah, 2 bolts for the fence, 4 bolts for the feeder, lock washers, and the handle. There's sort of 3 models of this that come up in size based on horsepower and if it has this roller fence. I decided to go with the larger model that had the roller fence and more horsepower due to the size of the material that I'm gonna try to be resawing on this. This bandsaw is a little small in this direction because it's suited for tall resaws and less so large bandsaw area. So we're gonna have to make a couple adjustments to its mounting position. This unit, the AF19, comes with the whole feeder assembly, the roller fence, adjustable roller fence, and templates, manual, and a hardware kit. And you line up the template with the tip of the blade, and it gives you the hole locations, right? If I were to use this exact hole locations for the fence, it's gonna keep that mounting point way back here. Well, why don't we just put it on there? Oh my God, this is so heavy. For my application, because of the size of the bandsaw, there's a limit to how much I can resaw. Now, this is totally fine. Usually you're resawing 8/4 material down to thinner pieces. And so I can totally fit all my pieces that I'm gonna need to resaw between this maximum opening and the blade. Also, at this position, when this is all the way forward to the blade, it's not very balanced. This is all the way extended out and not supported. And because I'm never gonna be moving it back to where it is balanced, I'm gonna mount this much closer so that I have that adjustability to its maximum opening and it's balanced. You can see even when it is all the way extended, it's not balanced, but it's a lot more supported with the armature this close. I have a little bit of wiggle room. You never want to take everything to the extents of its travel, so it's basically at the limit in any position. So I basically left 3/16 of an inch here, which I'm never going to have to adjust, but it's not at the end of the travel. So what I'm going to do is I'm going to mark where this hole is and use the template to find the location of the other hole and make sure that is lined up on the fence. They give you some adjustability with the size of these holes to adjust the position of the fence this way and that so that you can adjust for blade drift. So I want to make sure that the initial holes are very square to the table. I don't know if you can see it on camera, there's a very light scribe line that I scratched into the metal based on the center line of this circle area. So let's get that template on there. It gives you the dimensions. So we got 110 millimeters from the center point of this circle, which I could only get half of it because of the clearance on the thing, to the other one. So that clearance hole was 11 millimeters. From the edge of my permanent marker, that'll be 5.5 to the edge. Probably overly precise, but it's not gonna hurt anything. 110 to the next center line. All right, we got our 2 center punches for the fence, and now let's move on the marks for the feeder itself. All right, so place the other template right on the bandsaw table, line this tip up with the tip of the blade. That's gonna determine your forward and backward spacing. On mine, my holes dictate that it basically falls off the table. So in lieu of making a bracket or some sort of armature to hold this, I'm gonna move the whole thing inward, which will reduce my maximum material size, but it'll allow me to not have to make anything to get this to work. But before I do that, I wanna roughly mark where this position is gonna be so that I can check to make sure that there's no interference with the feeder and the blade, because that's the last thing you wanna do is send a board through and have it snap back at the end and shred your blade. Because on some of them, they're plastic wheels. This one has a metal wheel, so if it hits the blade, it's a disaster. Oh man, the manual says this is 200 pounds. I don't think it is. Oh, it's backwards. Oh my God. It is pretty heavy though. All right, so you see it's gonna snap back into the blade in its current adjustment, but this is the stopper that'll prevent that from happening. Because when it pivots, it pushes that. So if that's adjusted correctly, it'll never hit the blade. But I believe that template, I'm sure, is so that this pressure point is in the right position relative to the blade. So we're gonna go with that. So it turns out this line is exactly on the edge of a rib, so I can't have the center there. So we're gonna move the whole thing this way, and the closest it can get to the edge is here because there's a big skirt around this cast plate. So, here's a situation where they give you a template. In an ideal world, everything is gonna work, but you have to deal with your application. And because we're moving just a little bit in the nature of this device, it's not gonna be a problem. So for a M10 1.5, it wants a tap drill of 0.3346 inches, 0.332, 0.339. So we're gonna go with an R drill bit as a final size. Better to err on the side of a couple thousandths over so that we're not hurting our tap. I wish I owned a magnetic drill. This would be perfect for this. I rented one to work on my shaper, but I don't have one right now. So a steady hand, the trusty Makita drill, and a 1-2-3 block as a way to sight in our drill bit. We'll just take it slow and keep the drill bit square. Last thing to do before tapping is I'm going to take a zero flute countersink and give each one of these holes a nice little countersink so that the tap centers itself pretty easily. Cast iron, often you're not tapping it with a lubrication, so no need for tap magic or anything like that. Before we mount anything to this table, I'm going to take this machinist stone and stone the holes so that there's no burrs or anything above the surface. Hit the thing with a little bit of acetone to clean everything up, and then spray on my favorite Glide coat to protect the metal. I got the blade up to full tension here, and I'm checking that it is square to the table, which it might be a little off. I really want to lock down this table because there's going to be a lot of weight on the outside edge, and I don't want it to sag over time. It's pretty good. And the manual wants you to line up, wants you to get the fence in place, loosely attach it, and then line it up with a ruler that's parallel to the blade. Fortunately, I have this huge 2-inch blade on it, so I can see almost if it's parallel. I mean, it's pretty good. I mean, as far as I can tell, that blade is square to this front edge of the casting. It's not a machine surface, but it'll do. So then what I'm going to do here is I'm going to bring it back to this, just past here, and I'm going to scribe in a little reference line for myself. It's just a hairline that when I bring the fence on and off, I can line it up knowing that this is a perpendicular line to the front of the table here. Before we throw this fence on here, I was going to do the same thing. Best practice, make sure there's no burrs on the bottom here. It's smooth. Oh, there's some gunk on here. And I'm just going to hit it with this lubricant. You can use like a light machine oil or something, just so that if there's any moisture that sneaks up under there, it doesn't start causing rust between the two surfaces. So while it's loose, I can see my scratch mark there. I can still pivot this a little bit, so I can bring it right in there. You can see that this is lined up with the scratch mark there. Yeah, that's pretty good. Right along the hole mark. Obviously this can be adjusted then a little bit pivoted for blade drift, but I want to start from a known position. And we'll just snug it down. So I can go obviously right up to the blade, which I don't want to do, but I can cut some pretty thin veneers. I think 3 millimeters is what they say is the you don't want to get any closer to that. And then if I pull it all the way back until it hits the side column, I can resaw, let's say, if the blade is perfect, why don't we say 57 millimeters, which is a little over 2 inches, so 8/4 rough, which isn't bad. That's not bad. I mean, I don't break down lumber like big pieces on this machine. I'm going to be probably taking thin veneers in this range for the majority of the use case of this machine. Okay, so the feeder's on, nice and solid. Nice that it's not going to fall on the floor and smash my foot. Instructions say you don't want this to get any closer than 5 millimeters. I don't want this metal roller to hit this, expensive blade with carbide teeth and just shred it. And there's a stop that I'm going to set. So first I want to see where this impacts. Yeah, so I basically don't want it to come any closer than about here. I mean, the thing is, with the rollers I have with the teeth on it now, any material that I feed in at the end of at this stage, if it was this close to the blade, it's going to get marred up on one side, which is going to need to be planed out, and it's going to have bandsaw kerf on the other, or bandsaw cut on the other side. So you got to realistically think how much are you going to take off at the very end. So it's okay if I'm a little wide on this. So I'm feeling pretty good about that. The manual gives no guidance on how much tension this spring should have, but at the moment, at this closed position, there's almost no tension on it. And you see how when you pull this back, it increases the tension. I'm gonna just snug it up, and that way when I'm testing it, I can always add a little more if it starts tearing through the material. This is definitely a trial and error thing on the tension, but that feels pretty good. They supply it without a plug because everybody's application is different. I'm going to tie this into the power supply for the bandsaw itself. At full load, this I think doesn't draw more than it's like 2 amps at 240. So there's plenty of current available on this machine. So power comes in down here, and these terminal blocks connect to the contactor. So basically, these two lines are my constant power when the circuit breaker's on and the ground. So probably what I'm going to do is I'm just going to add a little fitting up here and run a little pigtail with an outlet on it so that I can remove the machine without it being tied into this. Nice. That was extremely unpleasant and really cramped. Before I test it, I want to pull it back and lock it in place. There's a locking pin here, so you pull it and then lift this up, and now it's tensioned, but it's not anywhere near the blade. The way this machine has speed adjustments, it has the classic turtle rabbit slow fast mode, but then it also has a set of pulleys, so it gives you a bunch of different speed combinations. We got 60 hertz. Looks like we're at the middle of 5, so that gives us 14 feet per minute, 4 meters per minute in turtle mode, 28 feet per minute, 8 meters per minute in rabbit mode. I guess I'm gonna have to play with this to see what works well with different materials. I'll probably start it out at turtle mode with what it has, so I don't need to change the belt and see how it works. Oh yeah, it's quiet. It sounds powerful. It's rare. There's no vibration, hardly any vibration here, and it's just you can imagine if you get your arm caught in here, you're gonna get just smushed and sliced. Let's see what rabbit mode is like. Oh yeah, that's fast. So I think it's probably time to do a little resawing. All right, let's get this set up for the first test. So I got the blade tensioned, I checked it. It's running true. I'm gonna bring this in. Let's try something like this. Not too thick. I don't want anything weird to happen. Because I haven't messed with anything about the drift, so I don't know how this is gonna go. I got a piece of scrap cedar here that I jointed a right angle on. See, that hits that. That's not good. That's good I tested. Gotta bring this guide up a little bit. All right, that'll prevent some trouble. Oh, man, this is making me nervous. I'm tempted to take a pass without the feed just to test how it goes. I don't want the drift to cause a problem. Okay, that was actually really good. I mean, this cedar's so soft, blade's sharp. I like this roller fence. It's really nice. I could totally see using this with this off of it for larger stuff that goes out in this direction. I'm confident that I can bring this a little closer. And why don't we do it for real this time? Wow, that is really nice. I mean, even at fast speed, it flew through that cedar. I mean, I love cedar. It's nice and soft. It really just blasted through there. While I do have to test this on some of the other woods I use, because this is just so soft, it's not putting up any resistance, this is extremely smooth. The consistency of feed really makes for a better cut. I think that was what I was hoping would happen, and I'm glad it did. Because when you're hand feeding and you pause to move your hands, any jiggle will make that blade sort of make some saw marks in here, whereas a consistent feed keeps a very consistent, smooth cut. And so the cleanup on the planer for this is negligible, which means ultimately the whole point of this thing is to get more wood out of a piece of rough stock. And this is with this huge 2-inch, like 1 tooth per inch carbide blade, which has quite a serious kerf. So I'm really happy with that. As I expected, those feed rollers made these little mars, these little indentations on the wood. And this is Western red cedar, so this is some of the softest wood there is. And it's not that deep. It's not as bad as I thought. And you know, yes, it would ruin a finished surface, but if you're going to plane this out, it's not a whole lot to take off. So that's kind of a bonus. All right, so we got the Co-Matic AF19 installed on this bandsaw, and my initial impression is that it is pretty awesome. I like the cut quality with a consistent feed. My initial impression is that it's just super solid, really good build quality. This is the second Co-Matic machine I got. I actually got a great deal on a feeder for my shaper used on Facebook Marketplace or something. And I was impressed with that, and this just continues being just a solid piece of hardware. There's no shift in this. This is really heavily built. This is a professional tool, and it's built, you know, professionally. When you spend money on a piece of equipment, you really want it to make you happy when you install it, and I am happy. So I'll probably do another video on this power feeder after we've used it for quite a bit and I really get a handle on the speed of the feed mechanism and how it performs with a different height and type of wood. If you have any questions about the install or this thing itself, throw those in the comments and I'll address them in the next video. But until then, thanks for watching this. I hope it was helpful to somebody, and we'll see you next time.